All right, let's demystify data analytics and forget all the complex jargon for a minute. The best way to think about it is like a toolkit. Each tool has a very specific job. And by the end of this, you're going to know exactly which one to reach for to turn all that raw data into smart, confident decisions.
So here's the big question, right? We are all swimming, maybe even drowning, in data. We've got spreadsheets, customer feedback, reports, it's everywhere. The real challenge is, how do we build a bridge from that huge mountain of raw information to a single, clear, confident decision? Well, the secret isn't actually hidden in the data itself. It's all about the questions you ask of it. So, we're about to walk through the 3 most important questions you can ask. And for each one, I'm going to show you the exact tool from our toolkit that's built to give you the answer. Let's get started. Okay, so the very first job of any data analyst is, well, it's to be a good detective. Before you can even think about predicting the future or trying to change it, you have to understand what's happening right now. You've got to see the whole unvarnished picture. And the first tool you'll probably reach for is visualization. Think of it as the magnifying glass in our toolkit. It's a really simple idea. Our brains are just wired for images, not for staring at endless rows of numbers. Visualization lets you instantly spot the trend, the weird anomaly, or the connection that would stay buried forever in a spreadsheet. But what if you don't even know what you're looking for? That's where unsupervised learning comes in. You can think of this as just turning the data loose and letting it organize itself. You don't tell it what to find, it discovers these natural groupings or clusters all on its own. For example, it could sift through patient data and reveal these hidden segments like high-risk frequent visitors or proactive wellness seekers, groups you didn't even know existed. So much of our most valuable data isn't in neat spreadsheets, it's just words. Customer reviews, support tickets, patient notes. To handle all this, we have a kind of mini toolkit. First, text mining helps us scan all that text for key patterns. Then, topic modeling finds the themes underneath it all. What are people really talking about? And finally, sentiment analysis takes the emotional temperature, telling us if the overall feeling is positive, negative, or neutral. And this is where the scale just becomes mind-blowing. Imagine your team has to read and categorize 50,000 patient comments. That's weeks of work, right? These tools can do it in minutes, and they'll identify the core themes with perfect consistency every single time. It's basically a superpower for understanding feedback at scale. And this is what you get. Not a mountain of text, but a simple, clear visual. Right away, you know the emotional pulse of your feedback. You've literally just turned thousands of messy, unstructured sentences into a single, measurable, actionable insight. Okay, so we've got a pretty good handle on the now, but the real power comes when we start looking into the future. The next set of tools in our kit, well, these are kind of like the crystal balls of data analytics. They help us use what we know about the past to make really educated guesses about what's coming next. The main tool for this is something called supervised learning. And the key word here is supervised because you get to be the teacher. You feed the model thousands of historical examples where you already know the outcome. For instance, you show it past patient data, and you explicitly label each one as showed up or no-show. The model then learns the patterns, so when you show it a new patient, it can predict how likely they are to miss their appointment. And the whole process follows this really clear, logical path. First, you need your textbook. That's your historical, labeled data. Then comes the study session, where the model trains on that data to learn all the patterns. Next up is the pop quiz. You validate its performance on data it's never seen before to make sure it actually learns something useful. And only after it passes the test do you let it start making predictions on new, real-world data. Now, this is a really, really crucial distinction to make. Some models are built to explain the past, to act like a microscope and help you understand why something happened. But supervised learning is different. Its one and only goal is prediction. It's a crystal ball, not a microscope. It cares a whole lot less about the why and is completely obsessed with accurately telling you what will happen next. So whenever your data has a timestamp on it, you need a specialist tool. Time series analysis is built specifically to understand data that unfolds over time, like daily website traffic or patient visits. It's brilliant because it can look at a messy timeline and break it down into its core parts. The overall trend, the predictable seasonal cycles like flu season, and then use all that understanding to forecast what next week or next month will probably look. And here's another super specialized tool that answers a very specific and critical question. How long until something happens? In fields like healthcare or engineering, you absolutely need to predict the time until an event, like a patient being readmitted or a machine part failing. That is exactly what survival analysis was designed for. This quote just hits the nail on the head. A standard predictive model, it might tell you if a patient is at high risk for readmission, but survival analysis is so much more powerful. It tells you if and, crucially, when. It calculates the risk over time, which lets you know exactly when the best moment is to step in.
So we've described the present, and we've predicted the future. Now, it's time for the final step. We're moving to the most advanced part of the toolkit. This is where we stop being passive observers and start actively finding the single best action to take to get the outcome we want. And this is the world of reinforcement learning. It's actually a bit like training a puppy. You create a digital agent that can take actions in an environment. When it takes a good action, it gets a reward. When it takes a bad one, it gets a penalty. It literally learns strategy through trial and error. So let's see how this works. Imagine our agent's job is to optimize hospital staffing. It tries a schedule, that's the action. The patient wait times change, that's the environment. If wait times drop, it gets a little digital treat. If they go up, a penalty. Now just imagine, it does this thousands of times per second. It's not just finding one good schedule, it's learning a master strategy, an optimal policy for how to react to any situation to keep those wait times low.
Phew. Okay, so we've seen tools to describe, tools to predict, and tools to optimize. The final step is just knowing how to pull the right one from your toolkit for the job at hand.
And really, it all boils down to this. If you remember one thing, please make it this slide. The power of data analytics isn't about knowing all the tools. It's about matching the right tool to your question. If you're asking what's happening now, you need a descriptive tool. If you're asking what will happen next, you need a predictive tool. And if you're asking the most powerful question of all, what should we do? Well, then you need an optimization tool like reinforcement learning. So there you have it. You've seen the toolkit, and you know that everything starts with asking the right question. The only thing left to decide now is, what problem will you solve first?